Alright, so in the two previous videos, we worked with some examples pertaining to indices. The goal of this video is to continue from where we stopped, and then particularly to introduce some more examples following one of the laws of indices, which we discussed this way. So if you check through rule number 4, we have a particular scenario where we have x to the power of a all to the power of b is equal to, when we have this particular kind of setup, you take the inner power and the outer power, you multiply them both, and you have x to the power of ab. So the examples we will take in this video will particularly be in the line of something like that. So let's see, we have 5 questions to go through, and let's get into them. Okay, so those are the 5 questions that we have, and let's try and solve them together. So the first one we have is we have A. Now it says open the square brackets. We have 3g all the power of 2. Then in another bracket we have all raised to the power of minus 2. So in this one, the idea is that let's just first solve what is inside bracket. So we have that to give us we're going to have the square bracket anyway. So 3 raised to the power of 2 is a 9, and g raised to the power of 2 is g squared. So what is really going on is that we have g raised to the power of 1 in the bracket. 1 times 2, following the rule number 4 we just mentioned, will give us a 2, and that is what we have here. Okay, so and that will give us all to the power of minus 2. Okay, so then the next thing to do is to apply the negative power. So from what we learned so far, whenever we have a negative power, we take a 1 over, we can leave it in normal brackets now, the rounded brackets now. So we have 9g squared all to the power of 2. Now we take it because the negative power applies to everything there. Okay, so we have 1 over 9g squared raised to the power of 2. Okay, so what do we do from here? We say let's go with this. We have it to be 1 over. Now everything in this bracket is affected by this power of 2. So 9 to the power of 2 is 9 squared. So we have 9 to the power of 2 and g squared raised to the power of 2. From the law of indices, we know that these two we multiply 2. In the case of 9, it is like saying 9 to the power of 1. Now 1 times 2 is a 2. Now g squared raised to the power of 2 is like saying g raised to the power of 2 times 2, which give us 1 over 81 g to the power of 4. Okay, so that is the answer to the question. Let's take the next one. So in the next one, we have minus 2x to the power of 6 all raised to the power of 4. Okay, so what do we do here? Now we have your minus 2x to the power of 6 all to the power of 4. Now the power of 4 is going to affect everything in the bracket. So in the case of the minus, we have something like this. We have minus, right? We're going to have minus times minus times minus times minus. This is what minus to the power of 4 looks like. So now we know for sure that minus times minus is a plus. So multiply by minus times minus is a plus. So at the end of the day, we have minus plus times plus, which ends up giving us a plus. So a prerequisite to that is that you know how all of this works, that your minus times minus is a plus, your plus times plus is a plus, your minus times plus is a minus, and your plus times minus is a minus. The idea is that once we have the same operator, like minus and minus, is going to give us a plus as an answer. But if you have different operators multiplying each other or dividing each other, we are going to have a negative sign as our answer. So that's the idea there. So in this case now we can group it in twos. Minus times minus will give us a plus. So this is the times, and minus times minus is a plus. So a plus times plus ends up being a plus. But the general rule is this, is that whenever you have this stuff going on in even number amount of times, for example, it goes on here for 4 times, it will end up becoming a plus, right? But if it goes on for an odd number amount of times, it will end up becoming a minus, right? So that's the idea there. So if you have it to be plus times plus times plus, okay? So this is odd amount of times, but it is the same plus, basically. It's plus. Plus will always give us that, but I'm specifically referring to when you have minus. Now, negative to the power of an even number will give us plus. Negative to the power of an odd number will give us minus. So this was a poorly chosen example, where we have a minus times minus times minus. Minus times minus is a plus multiplied by minus. So plus times minus is what? A minus, as we can see from there. So odd amount of times gives us a negative sign, and even amount of times gives us a positive sign. So the effect is that your minus to the power of 4 is going to be a plus. Now 2 to the power of 4 is like saying 2 raised to the power of 1 raised to the power of 4. That's like saying 2 raised to the power of 1 times 4. And we have x raised to the power of 6 all to the power of 4 will be x raised to the power of 6 times 4, following your rule of indices that we established here. Okay, so now we have this to be what? 2 to the power of 4, 2 to the power of 4, x to the power of 24. So, and 2 to the power of 4 is 16, x to the power of 24. So the third question now, we have C. We have it to be minus 5, open brackets, minus 3, y to the power of 5, all to the power of 3. Okay, so for this, we recognize the fact that the negative 5 is unaffected by the bracket. So we can rewrite it as minus 5 is basically multiplied by minus 3, y to the power of 5, all to the power of 3. So we have it to be minus 5 times whatever our answer here is. So minus 3 raised to the power of 3. Now minus to the power of an odd number is saying minus times minus times minus, which ends up being a minus. It's an odd number amount of times. So we have our answer to be minus. 3 to the power of 3 is 27. And y raised to the power of 5 all to the power of 3 is saying y to the power of 5 times 3. And now we have it to minus 5 times minus 7, 27. So the first thing first is that minus times minus is a plus. So we have that to be plus. And then the next thing we have is 5 times 27. So 5 times 27 gives 135. And we have that to be y to the power of 15. So that's the answer to that. Okay. Now the next question, question D. It says question D says minus c to the power of 5 all to the power of 2 divided by minus c to the power of 7. So that's what we have from here. Okay. So what do we do from here? We say, let's follow the same rules. So we say minus raised to the power of 2 is a plus, and we are left with c to the power of 5 times 2 divided by minus c to the power of 7. Here there's nothing outside of the bracket, so we don't need to do anything. Okay, so this is like saying plus c to the power of 10 divided by minus c to the power of 7. So now it's like the division rule is what we apply here. So first of all, plus divided by minus is a minus. Okay, so we have it to be c to the power of 10 minus 7 because we have the same item c and 10 minus 7. So that's minus c to the power of 3. Okay, so your question E is what we have last. We have that to be minus of v w squared times w over minus of v all to the power of 2. Okay, so what do we do from there? We open the brackets. So we have it to be minus vw squared times w over, now minus all to the power of 2. You can see the difference between the numerator and the denominator. In the numerator, the minus is outside of the bracket. In the denominator, the minus is inside the bracket, so it's affected by this. So minus all to the power of 2 will give me a plus, and v all to the power of 2 is v squared. Okay, so that's like saying minus vw squared times w. Now we cannot apply the law of indices to this directly because my w squared is being held by v. Okay, so what we need to do, we can split it or we can just multiply it by our intuition by saying minus vw squared times w to give me minus vw cube. Okay, and then we have this to be plus v squared. Now minus divided by plus is a minus. V here 1, v here will be left with a v. So we are left with w cube over v. That's minus w cube over v is the final answer to that. So I hope this set of questions also made enough of sense, and then we can basically handle it as well.